Our next presenter is Abbas Milani from the Materials and Manufacturing Research Institute at the University of British Columbia. Abbas Milani is a leading expert in modeling, simulation, and multicriteria optimization of advanced composite, biocomposite materials and their manufacturing processes. His interdisciplinary work links theoretical concepts to real-world applications, thereby enabling innovations for industry across Canada in manufacturing high-quality and cost-effective products. He is a Killam Laureate and the founding director of the Materials and Manufacturing Research Institute at the UBC. He has authored over 300 publications, including 5 books.
Hello everyone, my name is Abbas Milani. I'm the director of the Materials Manufacturing Research Institute at UBC and a principal investigator of the Composite Research Network in Canada. It's a great pleasure and honor to be here today. I'll be talking about the path to low-risk, knowledge-based composite manufacturing transitions to the factories of the future. So a little bit about our institute. It's a multidisciplinary, multi-campus research hub located at the Vancouver and Okanagan campus of UBC with the expertise of faculty ranging from engineering, medicine, all the way to social development, with 100 members from both academia and industry, towards 6 pillars of research that you see in the middle, with the vision of being a role model in linking basic and applied research in materials and manufacturing. My field of research specifically is on composite materials and their applications. So these materials are a combination of normally a polymer matrix with strong fibers, which when combined optimally, they can produce structures that are lightweight, but at the same time very strong. And because of that combination, you can see their wide range applications in aerospace, sporting gears, marine industries, automotive, and home constructions, to name a few. A challenge in manufacturing of these materials that it is a double-edged sword. So on one hand, you want to make high-quality, defect-free parts, and at the same time, you want to stay within a cost-effective production scheme. So within my field, textile fabric example, here you can see a flat part that has been turned to a hemisphere part. But again, if the setup is not optimized, you may see some wrinkles, which can cause repair, overhead costs, or eventually dispose of the material. So that means that the scientific research that is done at the university at the know-why level and engineering application that is being practiced at know-how by industry level should be well linked. But unfortunately for the composite material, there is this valley of death at the moment, and the Composite Research Network tried to bring this knowledge and practice framework where the industry, students, and faculty work together hand to hand in each project to translate that basic research to the best practice for industries. So as we do that, not only we try to address the current problem and the applied research for the industry, but also see how we can make a pull-push problem between the applied research and basic research so that we generate the next generation of the core research with bringing together different faculties and, for example, produce a new material that can be commercialized in a few years. And as we do that, the tools and facilities we use normally are on the constitutive modeling side, characterizing the material itself, forming the material as close as possible to what industry does, non-destructive testing to check the quality of the part, and eventually applying optimization and machine learning, or if you wish, artificial intelligence, so that we can trace back where those defects started. So we use also advanced simulations so that we can replace the costly experimental trial errors, no matter at the micro meso level, material science level, no matter at the macro level or processing and application level. This is an example of projects that is being done by Boeing and other partners that at some sharp corners of the parts in aerospace, there are wrinkles during the autoclave processing. So our simulation tools could capture those wrinkles and recommend best practices to avoid them so that the performance of the final parts are maximum. Another project is the material informatics, in my case the fabric composite informatics, where we try to make the material genomes and library of this material so that we can not only predict the properties of the current structure, for example here you see in the ski gears, at any time of the service, but also discover new materials without actually experimentally trying them. The way we do it, combined artificial intelligence with the advanced imaging techniques, in this case 3D X-ray microtomography, with mechanical and manufacturing sciences to make those prediction models and move more towards the Industry 4.0 based composite manufacturing. The third project I would like to give you an overview, we call it the Personal Belongings Career, or PBC, which is done with our community partner towards helping our homeless community to rebuild their lives. In this case, by replacing the shopping carts by composite alternative, which is functional, again lightweight and durable. And this project has been in the pilot stage and now being extended to other cities of Canada. I am also the cluster lead for the Biocomposite Research Network, which is a Canadian international network of academic researchers and industry associates working together towards circular economy, in this case by developing and applying more bio-sourced composite materials that are also biodegradable at the end of the life. I am also heavily involved in the Learning Factory initiative at UBC, which is going to be a composite factory of the future, where we try to make a digital twin of each stage of the physical factory workflow so that we can move towards Industry 4.0 based research in this field. At the end, I would like to acknowledge all my past and current students and all our funding agency and industry partners who made these projects possible. Thank you.